The last video we saw that how to get the value of z from the table, right? And we have done all this thing. So we got that this z will be plus 1.64 and this z will be minus 1.64, right? We know to calculate the value of z now. So if we don't have like when we are doing a test, so we need to calculate a z value, and then on the basis of that z value we need to compare with the z value in the table, and then we will lead to a conclusion. So when we need to calculate a z value, so we need to have this formula. Okay, it is for one specific type of question. So in this question you will be given sample mean, population mean, standard deviation, and number of people in the samples, right? In CR KOTHARI page number 202, illustration number 2, we can see that there is a question given which is like the sample is of 400 males, where the mean of the sample, which is like when we are adding the height of all the people in the sample, that particular 400 people, and dividing it by 400, we are getting this as the average of the sample. Now we need to say that are we taking that sample from the population whose mean is 67.39 inches. We need to check that the sample is collected from the population or not, collected from the population or not, right? So for this we will make two kind of hypothesis. Okay, H naught and H alternative. So H naught will say that the population mean, like the sample is taken from the population whose mean is 67.39, and alternative will be that the mean of the population is not 67.39. So as we know that when we are putting this sign, it is not like is not equal to, then it is a two-tail test, right? So for two-tail test we will do this kind of diagram, right? So here in the question it is given that we have significance level of 5%. Okay, so when significant level is 5%, so here it will come 0.025, right? Like 5% is 5% is 0.05, so half of it is 0.025, 0.025. So one it will be here, another will be this side, right? So 50 minus like 0.05 minus 0.025 is equal to what? 475. So we will check this thing on the table, and we will get to know that z value in the table is 1.96. Okay, so here z equal to 1.96 we will write. Here we will write z equal to minus 1.96, right? We wrote this much. Now we need to calculate the value of z. Okay, this is the standard one. This is the standard value of the z. Okay, so for calculation we are calculating x bar, which is the sample population, minus the population mean, okay, divide by the deviation, standard deviation of the population, divided by under root n. So we will put up the value, which will be like 64.47 minus 67.47 minus 67.39 divided by the significance, the standard deviation. What was the standard deviation in the question? It is given 1.3 inches. Okay, so 1.3 divided by under root of 400. So under root of 400 will be 20, right? So we will calculate all this, and we will get calculation. We will get 0.08 divided by 0.065 equal to, this is the answer we are getting. Okay, so our z calculated is 1.231, whereas z from the table is 1.96. Okay, so when we are making this graph, okay, here we are plotting Z value like this 1.96. Whichever is greater than 1.96, we are rejecting it. And if it is minus 1.96, whichever is lesser than 1.96, we are rejecting it. So our rejection region is Z, which equal to 1, okay, if greater than 1.96. okay. So what are the answer we are getting? We are getting 1.231. So if here it is 0, here it is 1.96, where will 231 will fall? It will obviously fall in this much area. No, it won't be greater than, here it will come 2, 3, 4, like that number can come. But we are getting 1.231. So it comes under acceptance area. So this area is acceptance, where we are accepting it. So when we are accepting it, we are agreeing that this this particular sample is taken from the population whose mean is 67.39 inches. So since Z calculated is in acceptance region, H0 is accepted. Okay, and we have to write that the population mean of this particular sample is 67.39. I hope that is clear.